fluid is preferred because oral fluid will give you an overview of the present state of your intoxication rather than metabolites in urine. Immunoassays have quantitative result saying that if the person is under the influence or not, but it doesn't give you quantitative results for which you need a blood test. Usually that will be done in a laboratory confirming your initial results. We are proposing a method based on capillary electrophoresis coupled with fluorescence detector that can be used on site for the testing of oral fluid for drugs of abuse. The machine is about 2 or 3 kilograms only. It's easily portable. It's in-house built. This is a manual operation system. We're using fluorescence detection at the deep UV range with a xenon lamp. The emission filters are interchangeable, and you can read more about the instrument and its specifications in a previous publication. So, the drugs of abuse of interest. We are mainly looking for the drugs that are mostly used in Europe. Amphetamine, methamphetamine, MDA, MDMA, MDA, and cocaine and cocaethylene. MDMA is also known as ecstasy, which MDA is a metabolite of MDMA, or it can be consumed on its own. And cocaethylene is formed in oral fluid when the person has also taken alcohol, which means even more impact on their impairment. In addition to amphetamines and cocaines, you have other drugs that have native fluorescence, like psilocin, LSD, fentanyl. They all have native fluorescence, and they are positively charged at acidic pH. This is our main methodology. The background electrolyte is consisting of phosphoric acid and nitrous base at pH around 3. We're using negative voltage, and the injection is done hydrodynamically. We have 2 internal standards, and the whole run takes under 10 minutes. Psilocin, LSD, and fentanyl will also come with the same background electrolyte, but we're still doing research to further optimize results. So, the sample handling. The oral fluid collection is a big important step because when you're under the influence of drugs, you might have the dry mouth effect. Therefore, the option of just spitting in a cup might not be available. We're using, for this research, we were using salivate collectors that are cotton swabs that the person just puts in their mouth for 2 minutes, after which the cotton swab was centrifugated. After the first centrifugation, the oral fluid retained in the cotton swab was around 0.28 grams, meaning that the amount was fixed. The quantification was possible to oral fluid. After which we added additional acetonitrile, centrifuged the sample again, and the second centrifugate was then used for the analysis. We also evaluated recoveries at 2 concentrations for each of the drug of abuse. The recoveries ranged from 11 to 35%, which is not a lot, but as we'll show you later, it wasn't an issue. So the whole method is validated according to the EMA guideline. The precision was between 0.7 and 5.5%, or within run between run under 12% and accuracy under 10%. We also evaluated the uncertainty, which was under 30. The detection and quantification limits were also evaluated using the salivate collector, and you can see that for amphetamines, the levels are way higher than for the other drugs, which is due to the excitation and emission wavelengths used. Other than that, we got detection and quantification limits around 6 and 30 and 10 and 50 nanograms per milliliters, which are below the recommended cutoff limits for oral fluid drugs detecting from the Driving Under the Influence Act and from the Workplace Testing Society, meaning that our method with the salivate collector, even with its low recovery rates, will give you still good enough sensitivity to detect drug abuse. We also tested the method on real samples with the instrument on site with the cooperation with the Estonian police for 3 years in Weekend Baltic Festival in Pärnu, Estonia. We collected over 110 samples from the people under the suspicion of being intoxicated. And here are some electropherograms showing some results. We found ecstasy, cocaine, and additionally tyramine. I will talk about tyramine on a few next slides. But overall, we caught mostly ecstasy, which was, we were assuming that ecstasy will be mostly used because it's a beach rave party. We also found cocaine and THC. THC was measured using a different methodology, which was also usable with this machine. We didn't find any amphetamine or methamphetamine, but it was due to the lack of sensitivity of the limits of detection. The results were quantified also for MDA, MDMA, cocaine, and cocaethylamine throughout the years, with MDMA having quite a wide range, because the people were actually brought from the festival itself, so the intake was quite recent. We also did a comparative analysis with HPLC-MS to see how the methods would compare, and we found a good correlation between the quantifiable results with both the CE fluorescence and HPLC-MS, saying that our results were in good correlation. So, speaking about tyramine, because in saliva you can also find endogenous compounds. At first we didn't know the additional peak was tyramine, so we had a few months actually where we tried to figure out which could be easily seen at this wavelength. So we figured it out, and it was tyramine. So what do you do at a beach party? You drink, you smoke. And a high level of tyramine is actually shown to be in people who smoke, and alcohol also helps you to bind it more in your system. So we found a lot of smokers, and we detected that in smokers you can see a tyramine peak, which was also confirmed by HPLC-MS to be tyramine. So we can also see that this method can be used to detect endogenous compounds, because a high level of tyramine can also be associated with high blood pressure or headaches, and with a hangover actually also. So this method could be used for self-repairing molecules in your system. So, in addition, we did a selectivity study where different pharmaceuticals were evaluated, as well as metabolites for the drugs of abuse and other drugs of abuse for the method. We found a few pharmaceuticals that could be detected in bodily fluids with this method. They did not interfere with our drugs of abuse. They had a different migration time, but they could be seen, which gives us the possibility to presume that this method could also be used for pharmaceutical detection from oral fluid for the at-home pharmaceuticals. And in summary, we had a portable CE fluorescence detection instrument for on-site detection. All of the proposed detection limits were under the suggested cutoff limits for both road and workplace detection. The precision and accuracy were under the 15% rate, so they were fulfilling the EMA guidelines. 110 waste samples from Weekend Baltic Festival were detected with good correlation to HPLC-MS. Better detection for amphetamine and methamphetamine are needed, so we're working on other wavelengths to see if we can have better detection limits so we can actually detect them in oral fluid and have lower ranges. And the possible future outcome should be real-time level pharmaceuticals in oral fluids for people at home, or endogenous metabolites and biomarkers. This is our research group, and I would like to also thank the financial support, and thank you for your attention.
Thank you very much. Is there any question? Yes.
Thank you very much for this very nice and interesting approach. I have just one question. Do you see a chance maybe to extend this beautiful method for novel psychoactive substances such as methadone, MDPV and those?
Yes, of course we are. I am actually, this year I'm trying to do synthetic cannabinoids, for example, and just changing the background electrolyte, of course, yes, but because this was at first with Estonian regional, it was a project that they wanted, so they precisely said for most commonly used drugs, but of course, yes, other drugs like psilocybin for magic mushrooms and those, yes.
Okay, thank you so much.
Okay, is there any other question? I just have one question. How can you improve the recovery of the extraction method?
Yes, we have a poster actually for automated recoveries as well in this conference, but using different approach. At this point we were using a double centrifugation, which took away most of our oral fluid sample, but to use different collectors, for example, statuary collectors, oral fluids collectors, they have other collectors which might not have other possibilities to extract the sample from. So basically using other collection methods and other pre-processing as such. Yes.
Okay, thank you for this nice presentation. I have a small question concerning the validation of your method. So, according to the DNA EMA, have you investigated the stability also, because some of your compounds seems to be quite sensitive to oxidation, for example?
Yes, of course. We have covered the stability over 6 months. The samples are stable if they are, if the sample is prepared. But if the sample is in oral fluid, of course it's not stable because, for example, cocaines do not stay in water-based systems. But if they are centrifuged into acetonitrile, the samples are stable at least for 6 months, and you can reanalyze them. So you have samples for testing in other labs and for more testing, yes.
I have one more question. We noticed that your instrument is a homemade instrument. What is the configuration of your detector, fluorescence detector? Is it orthogonal, collinear, or is something?
It's a classical ortholinear 90 degree.
Orthogonal, this one. Okay.
Yes.
Okay. If there is any question, we can stop here and your presentation. Thank you very much for this nice presentation.